Hello, in this lecture we will find the value of 2 times AP or the size of 2 times AP. Actually, we have in the picture triangle ABC. Side AB of the triangle equals to 90 units, side AC equals to 70 units, and the side CB of the triangle equals to 50 units. And also we have a circle. The center of this circle is at point P, and point P is situated on side AB of the triangle. And also side AC of the triangle is tangent to the circle at point, we will call that point O. Again, side AC is tangent to the circle at point O, or the touching point between side AC and the circle is point O, and also side CB of the triangle is tangent to the circle at point, we will call that point E. Again, side CB of the triangle is tangent to the circle at point E, or the touching point of side CB with the circle is point E. In the next step, we'll connect points O and P together by a straight line. Actually, PO is the radius of the circle. I will call it R, abbreviation for radius. And the reason that OP is the radius of the circle, because the straight line OP starts from the center of the circle, that is to say from point P, and ends at point O, that is a point on the circle. And this is exactly the definition of a radius. A radius in any circle starts from the center of the circle and ends at any point in the circle. Okay? In the same way, we will connect points E and P together by a straight line. So we can say in the same way that PE is the radius of the circle. I will mark line PE as R for the same reason, because line PE starts from the center of the circle and ends at a point that is on the circle. Okay? Actually, we have a rule that in any circle, a radius and a tangent to that radius are perpendicular to each other. Okay, so for example, in our circle, PO is the radius of the circle and AC is the tangent to that radius. According to our rule, the radius is perpendicular to the tangent. That is to say, angle POA equals to 90 degrees, and also angle POC equals to 90 degrees. Okay, and in the same way, the radius PE, or side CB of the triangle, is tangent to the radius at point E. So according to our rule, the radius PE is perpendicular to the tangent. That is to say, angle PEB equals to 90 degrees, and also angle PEC equals to 90 degrees. Okay. So I will write down the rule. I will call it rule number 1. So rule number 1 states that in any circle the radius and the tangent to that radius are perpendicular to each other. I will read it again. Rule number 1 states that in any circle, the radius and the tangent to that radius are perpendicular to each other. So, for example, if we have a radius, let's call it R, and a tangent to that radius, let's call it T. The radius is perpendicular to the tangent, or to its tangent. That is to say, this angle equals to 90 degrees, and also this angle equals to 90 degrees. Okay? So it's true in any circle that a radius and the tangent to that radius are perpendicular to each other. We actually implemented rule number 1 in our specific circle, because in our specific circle we have radius, PO is a radius, and AC is the tangent to that radius. According to that, to rule number 1, they are perpendicular to each other. So the radius PO is perpendicular to the tangent AC. That is to say, angle POA equals to 90 degrees, and also angle POC equals to 90 degrees. And in the same way, we have radius PE. PE is the radius of this circle, and we have side CB of the triangle that is tangent to that radius. And for that reason, according to rule number 1, the radius is perpendicular to the tangent, to its tangent. The radius is perpendicular. The radius is perpendicular to CB. The radius is perpendicular to CB, that is the tangent to this radius. That is to say, angle PEC equals to 90 degrees, and also angle PEB equals to 90 degrees. Okay? In the next step, we will draw a perpendicular from point C to side AB of the triangle. So from point C we draw perpendicular to side AB of the triangle, and we will call to the touching point between the perpendicular to side AB of the triangle capital M. That is to say, CM is perpendicular to side AB of the triangle. That is to say, angle CMB equals to 90 degrees, and also angle CMA equals to 90 degrees. Okay? Again, CM is perpendicular to side AB of the triangle. For this reason, this angle equals to 90 degrees, and also this angle equals to 90 degrees. In the next step, we will define angle CAB as alpha. Angle CAB or CAP, CAM, it is the same. And also we will define angle CBA as beta. And we will also define AP as x, or AP equals to x. As you can see from the picture, side AB equals to 90 degrees and AP equals to x. So PB will be equal to AB minus AP. That is to say, AB is 90 units minus AP, that is x. So in total, PB equals to 90 minus x. Okay? In the next step, we will focus on the right triangle AOP, and also we will focus on the right triangle ACM. AOP is a right triangle because angle AOP equals to 90 degrees, and also ACM is a right triangle because angle APC equals to 90 degrees. Any triangle that one of its angles equals to 90 degrees is defined as a right triangle. Okay, so first of all, in the right triangle AOP, sinus alpha equals to the ratio between the side that is in front of alpha, the side of triangle AOP that is in front of alpha is actually side OP of the right triangle, divided by the hypotenuse of triangle AOP, and the hypotenuse of the right triangle AOP is actually AP. Why AP is the hypotenuse? Because actually the other two sides are perpendicular to each other. In the right triangle AOP, side AO is perpendicular to side OP. So those two sides, AO and OP, are called the perpendiculars of the right triangle, and the third side must be the hypotenuse of this right triangle, the right triangle AOP. Okay, so we got that in the right triangle AOP, sinus alpha equals to OP over AP. Sinus alpha equals to OP, that is the side that is in front of angle alpha, divided by the hypotenuse of the right triangle AOP, and the hypotenuse of the right triangle AOP is actually AP. Okay, so sinus alpha in the right triangle AOP equals to OP over AP. Now we will focus on the right triangle ACM. In the right triangle ACM, sinus alpha will be equal to the angle that is in front. Sinus alpha will be equal to the side that is in front of angle alpha, and the side that is in front of angle, front of angle alpha is actually CM. CM is in front of angle alpha, divided by the hypotenuse of the right triangle ACM. And the hypotenuse of the right triangle ACM actually equals to AM. The hypotenuse of the right triangle AMC equals to AC. I will explain why AC is the hypotenuse of the right triangle ACM, because actually the other two sides of the right triangle ACM are perpendicular to each other. So the other two sides are considered as the perpendiculars. So if we have two sides that are the perpendiculars, the third side must be the hypotenuse. So AC is the hypotenuse in the right triangle ACM. So in total, in the right triangle ACM, sinus alpha equals to CM over AC. Okay, so we got in total that sinus alpha equals to OP over AP, that equals to CM over AC. Now we will copy this equality, and we will call this equality equation number 1. Okay, So I repeat again, we copied this equality here and we called it equation number 1, OP over AP equals to CM over AC. But as you can see from the picture, OP equals to the radius of the circle. So we can write down that OP equals to R. And also we defined AP as X, AP equals to X. And AC is given to us in the question. AC equals to 70 units. I write it down. AC equals to 70 units. So we got that OP equals to R, AP equals to X, and AC equals to 70 units. So actually we can put the data in equation number 1. Okay, we'll do it now. So in equation number 1, I substituted OP by R because OP equals to R. And then I substituted AP by X because AP equals to X. I left CM as it is. And I substituted AC by 70 because AC equals to 70. Okay, in the next step we divide both sides of the equation by CM. Okay, it is allowable to divide the equation by CM because CM is actually the perpendicular to side AB of the triangle. So it must be a positive number, it can never be 0. For that reason it is allowable to multiply the equation by CM or to divide the equation by CM. So we get that here we divided the equation by CM. So R over X divided by CM equals to R over CM times X. And then we divided this side of the equation by CM. Actually, CM divided by CM equals to 1. So we left with 1 over 70. Okay. CM is cancelled from the equation, from the side of the equation. CM divided by CM equals to 1. Okay, in the next step we'll multiply both sides of the equation by X. Again, it is allowable to multiply the equation by X because actually X equals to AP. Must be a positive number, it can never be 0, so it is allowable to multiply the equation by X. So we multiplied the equation by x. Here x divided by x equals to 1. So we left only with r again x divided by x equals to 1, so we left only with r over cm in this side of the equation. Okay, we have only r over cm, and here x times 1 over 70 equals to x over 70. Okay, it is x over 70. So we have the first equation that states that r over cm equals to x over 70. In the next step, we will do the same process on beta, and we will focus on the right triangle EPB. And we will also focus on the right triangle CMB. Again, we will focus on the right triangle EPB, and we will also focus on the right triangle CMB. So, first of all, we will focus on the right triangle EPB. In the right triangle EPB, sinus beta equals to the side that is in front of angle beta in the right triangle EPB, and the side that is in front of angle beta is actually EP, divided by the hypotenuse of the right triangle EPB. Again, it is very simple to find the hypotenuse because actually PE is perpendicular to EB. So those two sides, PE and EB in the right triangle EPB, are the perpendiculars of the right triangle EPB, and the third side, that is PB, is the hypotenuse of the right triangle EPB. So all we divide by PB. So actually, again, sinus beta equals to the angle that is in to the side that is in front of angle beta, that is to say EP, over divided by the hypotenuse of the right triangle EPB, and the hypotenuse is PB. So in total, sinus beta equals to EP over PB. Okay, now we will focus on the right triangle CMB, and the sinus beta in the right triangle CMB equals to the ratio between the side that is in front of angle beta and the side that is in front of angle beta is actually CM, divided by the hypotenuse of the right triangle CMB. Again, we know that CM is perpendicular to MB. For that reason, side CM and also side MB are the perpendiculars of this triangle. So the third side that is left, that side CB, that is the hypotenuse of the right triangle CMB. So actually it is divided by CB. So in the right triangle CMB, sinus beta equals to CM, the side that is in front of angle beta divided by the hypotenuse of the right triangle CMB, and the right triangle divided by the hypotenuse in the right triangle CMB, and the hypotenuse in the right triangle CMB is actually CB. Okay, in total sinus beta equals to Cm over Cb, and we got actually that sinus beta equals to PE over PB divided by Cm over Cb. Okay, sinus beta equals to EP over PB, that equals to Cm over Cb. We will do the same process as we did in sinus alpha. We will copy this equality and we will call this equality equation number 2. Okay. I repeat, I copied this equality here and I called it equation number 2, EP over PB equals to Cm over Cb. But according to the picture, actually EP is the radius of the circle, so we can write down that EP equals to R. And also PB equals to 90 minus 6 because it is AB, that is 90 units, minus AP, that is X. So PB equals to 90 minus 6. And CB is given to us in the question. CB equals to 50 units. Okay. I repeat again. AP equals to R, PB equals to 90 minus 6, and CB equals to 50 units. Again, we can put the data in equation number 2. Okay. So actually I substituted EP by R because EP equals to R. And then I substituted PB by 90 minus 6 because PB equals to 90 minus 6. I left CM as it is, and then I substituted CB by 50 units because CB equals to 50 units. Okay, again here we divide both sides of the equation by CM. So we divided the equation by CM. So in this side of the equation, R over 90 minus 6 divided by CM equals to R over CM times 90 minus 6. Okay, and in this side of the equation, CM divided by CM equals to 1. So here we have 1 and 50, we copied it here. So CM divided by CM equals to 1, and we have 50 here, so we put it here. So in the next step, we will multiply both sides of the equation by 90 minus 6. It is allowable to multiply the equation by 90 minus 6 because 90 minus 6 is actually PB. Anyway, AB equals to 90 and AP equals to X, so 90 minus 6 must be a positive number because AB, that is 90 units, is bigger than AP, that is X. So 90 minus 6 will be a positive number, it can never be 0, so it is allowable to multiply the equation by 90 minus 6. Okay. Repeat again, we multiplied the equation by 90 minus 6. So in this side of the equation, we have actually 90 minus 6 divided by 90 minus 6 equals to 1. So 90 minus 6 is cancelled, and we left only with R over CM. Okay, because 90 minus 6 divided by 90 minus 6 is 1, and we left only with R over CM. And here 90 minus 6 times 1 over 50 equals to 90 minus 6 over 50. Okay. So we got the equality that R over CM equals to 90 minus 6 over 50. This is from the second equation, but from the first equation, we know that R over CM equals to X over 70. So I write it down. From the first equation, we know that R over CM equals to X over 70. So we have two expressions for R over CM. So we'll create the third equation that states that R over Cm equals to R over Cm. Okay, the first equation is R over Cm equals to R over Cm, and in the next step we will substitute R over Cm in this side of the equation by the value of R over Cm from the first equation, that is to say x over 70, and in the other side of the equation we will substitute R over Cm by the value of R over Cm from the second equation, that is to say 90 minus x over 50. Okay, so actually we will substitute the value of R over Cm from the value of R over Cm in the first equation here, and then we will substitute the value of R over Cm by the value of R over Cm from the second equation. That is to say, we will substitute R over Cm by 90 minus 6 over 50. Okay? I repeat again. I substituted the value of R over Cm by the value of R over Cm from the first equation, that is to say x over 70, and in this side of the equation I substituted R over Cm by the value of R over Cm in the second equation, that is to say 90 minus 6 over 50. Okay, in the next step we will multiply both sides of the equation by 50. So I multiplied the equation by 50. So x over 70 times 50 equals to 50 times x over 70, and 90 minus 6 times 50 divided by 50 equals to 90 minus 6, because 50 over 50 equals to 1. So 50 is cancelled from this side of the equation, and we left only with 90 minus 6. Okay? In the next step, we'll multiply the equation by 70. Okay? Here we multiply the equation by 50. So we multiply the equation by 70. So 50x times 70 divided by 70 equals to 50x, because 70 divided by 70 equals to 1. So 70 is cancelled from this side of the equation, and we left only with 50x. Okay, and 70 times 90 minus x equals to 70 times 90 minus x. In the next step, we will open the brackets in this side of the equation. No, first of all, we will divide both sides of the equation by 10, or we will divide the equation by 10. So here 50x divided by 10 equals to 5x, and 70 times 90 minus 6 divided by 10 equals to 7 times 90 minus 6. So in total, 50 divided by 10 equals to 5, and 70 divided by 10 equals to 7. Okay, now we will open the brackets in this side of the equation. So we open the brackets in this side of the equation. 7 times 90 equals to 630, and 7 times minus 6 equals to minus 7x. In the next step, we will add 7x to the equation. So we added 7x to the equation. 5x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 630. In the next step, we will divide the equation by 6. So we divided the equation by 6. 12x divided by 6 equals to 2x, and 630 divided by 6 equals to 105. 105 units. Okay, but we, according to our definition, AP equals to x. Okay, so I will add the fourth equation that states that AP equals to x, AP equals to x, but if AP equals to x, then 2 times AP will be equal to 2 times x. So we got in the fourth equation that 2 times AP equals to 2 times 6, so 2 times 6 equals to 2 times AP, and for the fourth equation, for the third equation, we know that 2 times 6 equals to 105 units. Now we will combine equation 3 and 4 together, by creating the fifth equation. We actually can say that 2 times x equals to 105 from one side, from the third equation, but from the fourth equation we also know that 2 times x also equals to 2 times AP. Okay, so we will combine those two equations together by the fifth equation. So we can say that 2 times x equals to 105 units from the third equation, but we also know from the fourth equation that the value of 2 times x is actually equals to 2 times AP, so we can add in the fifth equation that the value of 2 times x is also equals to 2 times AP. I will repeat again. From the third equation we know that 2 times x equals to 105 units. But from the fourth equation we know that 2 times x also equals to 2 times AP. So we can add to the fifth equation that 2 times x also equals to 2 times AP according to the fourth equation. So at the end we got that 2 times AP equals to 105 units. Okay, I will write it down. So our final answer to the question is that the value of 2 times AP is equal to 105 units, or the size of 2 times AP is equal to 105 units. Okay, now I will summarize the lecture. We actually wanted to find out the value of 2 times AP, and we have a triangle ABC, and side AB of the triangle ABC equals to 90 units, side AC equals to 70 units, and side CB of the triangle ABC equals to 50 units. And also we have a circle. The center of this circle is actually point P, and point P is situated on side AB of the triangle, and also side AC of the triangle is tangent to the circle at point O, and also side CB of the triangle is tangent to the circle at point E. And we actually drew connected the points O and P together. We connected points O and P together. And actually OP is the radius of the circle, and we connected points P and E together, and PE is also the radius of the circle. And we actually have a rule that states that in any radius the tangent in any circle, the radius and the tangent to that radius are perpendicular to each other. Okay, so if you have radius and the tangent to that radius, then they are perpendicular to each other. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So we can implement rule number 1 in our circle, because we have radius, OP is the radius, and the tangent to that radius, AC is tangent to the radius. So according to rule number 1, the radius is tangent to the tangent. AC is the tangent. For that reason, angle POA equals to 90 degrees, and also angle POC equals to 90 degrees. And it is true also on this side, because PE is the radius, and the tangent to this radius is actually side CB of the triangle. For that reason, according to rule number 1, the radius is perpendicular to the tangent of this radius. The radius is perpendicular to the tangent of this radius, so actually angle PEC equals to 90 degrees, and also angle PEB equals to 90 degrees. And then we actually draw a perpendicular to side AB of the triangle. We call the touching point between the perpendicular to side AB of the triangle capital M. So CM is perpendicular to side AB of the triangle. For this reason, angle CM is 90, angle CMB is 90 degrees, and also angle CMA is 90 degrees. And then we define angle CAB as alpha, and also angle CBA as beta. And then we define AP as X, so PB must be equal to 90 minus X. Okay? And then we focused on the right triangles AOP and the right triangle ACM. In the right triangle AOP, we can say that sinus alpha equals to OP over AP, and in the right triangle ACM, we can say that sinus alpha equals to CM over AC. So in total, we got that sinus alpha equals to OP over AP, that equals to CM over AC. We actually copied this equality and called it equation number 1. But we know that OP equals to R and AP equals to X according to our definition, and also AC is given to us, is equal to 70 degrees. So we can put this data in equation number 1, and at the end we got that R over CM equals to X over 70. This is the first equation, and we created also the second equation by relating to beta and sinus beta, and we focused on triangles PAEB and triangle CMB, the right triangle CMB. We know that sinus beta in the right triangle PEB equals to PE over PB from one side, but sinus beta in the right triangle CMB equals to CM over CB. So actually in total we got that sinus beta equals to EP over PB, that equals to CM over CB. And again we copied this equality and called it equation number 2. But we know that PE equals to R, and also PB equals to 90 minus 6, and CB equals to 50. So we can put this data in equation number 2, and at the end we got that from the first equation that R over CM equals to 90 minus 6 over 50, but from the first equation we know that R over CM equals to X over 70. So we can create the third equation that states that R over CM equals to R over CM, and then we substituted the value of R over CM by the equation number 1, the value of R over CM from equation 1, that is to say X over 70, and then we substituted the value of R over CM by the value of R over CM for the second equation. Okay, so in total we got that X over 70 equals to 90 minus 6 over 50, and at the end of the process we actually got the equation that 2 times x equals to 105 units, but we know according to our definition that AP equals to x, so we created the fourth equation that AP equals to x. So if AP equals to x, then 2 times AP equals to 2 times x. So then we combined equation 3 and 4 together, and we got to the conclusion that 2 times x equals to 105, that equals to 2 times AP, or we, at the end we have the equality that states that 2 times AP equals to 105 units, so the size of 2 times AP is equal to 105 units. Okay, thank you very much.